Similar to yesterday, I wanted to give you a resource to help you with going over this review as you prepare for your test tomorrow. So feel free to jump to any of the sections that you need to, watch whichever parts you need, or watch them a couple of times, jump around, but use this for whatever pieces you need the extra help with to help you prepare for your test. So first part, this one is focused on multiplying and dividing, and one of the things we had to do a lot of is turning some fractions into decimals or decimals into fractions at various times. So there are some common ones that we've talked about in class that we just kind of need to know these by memory. We need to know what these are. And one of the hints I give you is for some of these, think about money. So like start with this one, 1/2. So what is 1/2 as a decimal? Some of our first instinct is just to put the 2 as our decimal, 0.2, but that's not really 1/2. So I always think of it in terms of money. What's half of a dollar? Well, it's 50 cents. So 0.5 or 0.50 is 1/2 as a decimal. It's half of a dollar. So how about A, 1/4? Well, think about money. What does it take 4 of to make a dollar? What's 1/4 of a dollar? Well, that's a quarter. That's 25 cents. So 1/4 is 0.25. 3/4. Well, think of 3/4. How much is 3/4? Well, that's 75 cents. So 0.75. Now you could also do what we did yesterday. You could do the numerator divided by the denominator and divide it out. That'll always work, but there are some that are commonplace enough that we just want to kind of commit them to memory. So how about the next two, 1/10 and 7/10? Well, if you remember from when we talked about these in class, use their name, 1/10. That means a 1 in the tenths place. So 0.1. That first decimal place is my tenths place. So the next one, 7/10. That means a 7 in the tenths place. So 7/10. All right. Now we're going to quickly review our rules for multiplying positives and negatives. So if one number is positive and one number is negative, remember our rule for multiplying and dividing is our answer is going to be negative. Doesn't matter if it's the first one that's negative and the second one that's positive. If one's negative, it stays negative. But if you have two negatives, so a negative times a negative, think of those two as kind of canceling each other out, and our answer goes back to being a positive. So let's see that in action down here. Negative 25 times 4. One negative, so it's going to stay negative. 25 times 4 is 100. Negative 9 times negative 8. Negative times a negative is a positive. 9 times 8 is 72. Next one, 72 divided by negative 6. So a positive divided by negative is a negative. 72 divided by 6 is 12. And then negative 21 divided by 11. Remember that fraction bar really just means divide. Well, a negative divided by positive is a negative. 121 divided by 11 is 11, negative 11. All right, next ones we're going to do a little bit of work. So here we're multiplying decimals. So first things first, take care of our sign. A negative times a positive means our answer is going to be negative. Now we just worry about multiplying. So we set up our multiplication. Remember, we don't need to line up our decimal points, and we're just going to go ahead and multiply. We're going to start by multiplying that 5 times all the numbers up top. So 5 times 3 is 15, carry the 1. 5 times 2 is 10, plus the 1 we carried is 11. And then 5 times 7 is 35, plus 1 is 36. Now we're done with that 5, and we're going to multiply by the second number. So to make sure things are lined up, we always start with that placeholder 0 in that second row to kind of bump everything over. So now I'm under that tenths or tens place because that's where my next number is. 5 times 3 is 15, carry the 1. 5 times 2 is 10, plus 1 is 11. 5 times 7 is 35, plus 1 is 36. So I do all my multiplying. Now I'm going to add my numbers together. And then our last step is we got to place our decimal in our answer. Remember our rule. We count up how many decimal places did we have in the problem, or how many digits behind the decimal. Well, I had 1, 2, 3 digits behind my decimal. I know that other 5 kind of got lost. But there were 3 numbers behind my decimal place. So I'm going to come over 1, 2, 3 places in my answer, and I get negative 39.765. All right, next one. Now I'm working with my multiplying and dividing fractions. So remember, for multiplying and dividing, first take care of your sign. A negative times a positive is a negative. Then when we're dividing fractions, remember, instead of dividing by the fraction, we're going to multiply by its reciprocal. We're going to flip that second fraction upside down. Once it's a multiplication problem, now we look to see if we can simplify anything. So we can look vertically, top and bottom, or more often than not diagonally, and we look to see what could I divide out of 2 of those numbers. So for instance, 15 and 35 can each be divided by 5. So I can do that division now. 15 divided by 5 is 3. 35 divided by 5 is 7. So we divided those common factors out. Remember, one numerator, one denominator, and it simplified our numbers already quite a bit. Now we look for some more. How about 8 and 24? Well, those can both be divided by 8. 24 divided by 8 is 3. 8 divided by 8 is 1. Now, there's not always going to be something we can divide by, but we always want to look. We want to divide out as much as we can because it helps keep our numbers smaller and more manageable. When we're done, we remember that it's still multiplying. So 1 times 7 is 7. 3 times 3 is 9. And I get an answer of negative 7/9. Next one, negative 6 and 1/4 times negative 3 and 1/5. So a negative times a negative is a positive. Remember, for our mixed numbers, before we can multiply or divide with mixed numbers, we have to change them into improper fractions. To do that, we take our whole number times the denominator plus the numerator. So 6 times 4 plus 1 is 25, and the denominator stays a 4. Then I do 3 times 5 is 15, plus 1 is 16/5. All right, it's already a multiplication problem, so I don't need to flip anything, but now I want to look for cross-simplifying. So what could I divide out of a numerator and denominator? Well, 25 and 5 could each be divided by 5. So I get a 1 and a 5. 16 and 4 could each be divided by 4. So that gives me a 4 and a 1. When I think I've gotten everything, now I go ahead and multiply. Because remember, it's still a multiplication problem. So 5 times 4 is 20. 1 times 1 is 1. Another name for 20 over 1 is just 20. All right, now into our word problems. And off to the side of the word problems, I gave you some questions to ask yourself, because the trickiest part is deciding, do I want to multiply or do I want to divide? So here are some ways to think through it. An ant can travel 7.63 inches each minute. So 7.63 1 minute, and then another 7.63 the next minute, and on the longer it goes. So this question says, well, what if it goes for 3.5 minutes? How far could it travel? Well, the question asked is the distance going to get bigger, or are we breaking it up into little pieces? Well, for me, it's going to go 7.63 and another 7.63 and then another. So it's going to keep getting bigger and bigger. So that means I want to multiply. So for multiplying, we got 2 options. We can either change them both into fractions or both into decimals. I'm going to suggest for this one that we turn them into decimals, because that 0.63 is going to be tough to make into a fraction that we really want to work with. So let's change 3 1/2 into a decimal. Well, remember at the beginning we talked about 1/2 is really 0.5, so it really is just 3.5. So I want to do 7.63 times 3.5. So I start with the 5. 5 times 3 is 15. 5 times 6 is 30, plus the 1 is 31. 5 times 7 is 35, plus 3 is 38. Remember, when you start that second row of multiplication, you always start with that placeholder 0. Then we multiply with our 3. 3 times 3 is 9. 3 times 6 is 18. Carry the 1. 3 times 7 is 21. Plus the 1 is 22. Then I go ahead and add 5, 10, 17, 6, and 2. And then remember, our last step is to place our decimal in our answer. So there was 1, 2, 3 decimal places or digits behind the decimal in the problem. So we come over 1, 2, 3 digits in our answer. And we get 26.705. And since the distance they were going and the amount of time are both positive numbers, we know our answer is going to be positive. All right, back of the page. It says, Josiah ran a total of 8.25 miles in 1.5 hours. If he was running at a constant rate, how far did he run each hour? So we know the whole distance that he ran and the whole amount of time, but I just want to know a chunk of it. I just want to know an hour. Well, if he's only running an hour, the distance isn't going to get bigger. If he's going to go for a shorter time, it's going to get smaller. So I'm breaking it up into 1 hour chunks. That means I want to divide. So for dividing, we definitely want to make them into fractions. Dividing with decimals can get big and cumbersome and lots of digits. It's much easier to leave them as fractions. So let's turn 8.25 into a fraction. Well, if you remember, 0.25 is the same thing as 1/4. It's a 1/4 of a dollar. It's a quarter. So 8 1/4 divided by 1 1/2. If you remember from our problem on the front side, when we're dealing with mixed numbers, we got to change them to improper fractions first. So 8 times 4 is 32, plus 1 is 33/4. 1 times 2 is 2, plus 1 is 3/2. But it's a division problem. So then my next step is I got to rewrite it as a multiplication problem. 33/4 times, and then remember we flip that second fraction and make it 2/3. Now I want to go ahead and see if I can simplify things, make my numbers a little more manageable. So 2 and 4 can each be divided by 2. 2 divided by 2 is 2, or sorry, 1. 4 divided by 2 is 2. And then 33 and 3 can both actually be divided by 3. So 3 divided by 3 is 1. 33 divided by 3 is 11. Now I go ahead and multiply. 11 times 1 is 11. 2 times 1 is 2. And I want to know how many miles was he able to run? Well, this is an improper fraction. So ask yourself, how many 2's can go into 11? Well, I can take away 5 groups of 2, so that's my whole number. So think of it as I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I want to make groups of 2. So I can make 1, 2, 3, 4, 5 groups of 2. That's my whole number. And then how many are left over? Well, I have 1/2 left over. So 5 1/2 miles. All right. Now, the next one is actually kind of carries on from the same problem. It says if Josiah, same person from number 5, ran at that same pace, 5.5 miles per hour, how far could he run in 5 hours? So he could run 5.5 the first hour, 5.5 the next hour, 5. Do you notice how it's getting bigger and bigger and bigger the longer that he runs? That means we want to multiply. So 5 1/2 times 5. Well, same thing before. Change those mixed numbers to improper fractions. So 5 times 2 is 10, plus 1 is 11/2. 5 is really just 5 over 1. You can turn any whole number into a fraction by writing it over 1. In this case, there's nothing I can divide out. So I just go ahead and multiply. 11 times 5 is 55. 2 times 1 is 2. So I get 55/2. So we're going to do the same thing we did in the last one. How many 2's can we get out of 55? Well, I can do 2 times 27. Because 27 times 2 is 54. So I can take away 27 groups of 2. That's 54. If I took 54 away from 55, I would be left with 1/2. So in this case, if Josiah kept running for 5 hours, he would run 27.5 miles. Actually, a little bit more than a marathon. All right, almost done. Number 7 says an object is dropped out of a hot air balloon. So that means it's falling at a rate of 32 feet per second. So that's going to be a negative 32 because it's falling down. If it falls for 5.3 seconds, and each of those seconds it drops 32 feet, how far will it have dropped? Well, it's going to drop 32 the first one, and 32 the next one, and 32. So it's going to keep dropping each minute for 5.3 minutes, or 5.3 seconds, sorry. So that means it's going to get bigger, which means we want to multiply. So I want to do negative 32 times 5.3. Okay, for multiplication, leaving them as decimals is totally fine. No reason to make these into fractions if we don't have to. We just go ahead and multiply. So a negative times a positive is going to be a negative because it's falling. 3 times 2 is 6. 3 times 3 is 9. Remember, start that second row with that placeholder 0. And now I'm going to multiply with my 5. 5 times 2 is 10. Carry the 1. 5 times 3 is 15. Plus 1 is 16. Add it all up. And now I got to put my decimal in my answer. Well, there's one decimal place in my problem. So I'm going to come over one spot in my answer. And I get an answer of 169.6 feet. And it's going to be a negative because we were falling. All right, very last one. Corey has $20.80 in her lunch account. If she withdrew, remember, withdrawing means taking money out of your account. So you're subtracting that money from your account each day. So she's taking $3.75 out each day for snacks for a total of 5 days. So write and solve an equation to show how much money she has left in her account. Well, she's spending $3.75 each day times 5 days. Okay? And then that's coming out of her account with $20.80. So we're subtracting that $3.75 each day for 5 days. So let's find out how much that's going to be. So $3.75 times 5, 25, 7 times 5 is 35, plus 2 is 37. 5 times 3 is 15, plus 3 is 18. There were 2 decimal places in the problem, so there's 2 decimal places in our answer. So she's going to spend a total of $18.75 out of her $20.80. Well, let's subtract away what she spent to see what's left over. So gotta do a little borrowing here. I'm going to subtract, and she has $2.05 left in her account after buying those snacks 5 days in a row. All right, hope that helps as you're kind of tackling those problems. Hopefully spend some time preparing and be ready for your test tomorrow.